On the axes below, sketch the graphs of this equation. It's a cubic equation, as you can see here, with a negative x cubed, isn't it? When you expand this bracket, it'll be minus x cubed. And this curve here, y equals minus 2 over x, showing clearly the coordinates of all points where the curves cross the coordinate axes. Using your sketch, state, giving a reason, the number of real solutions to the equation. This, which is the first curve, is plus this, which is simply the negation of this, equals 0. So let's have a little look at this then. I've summarized the question here. So now we've got to draw this cubic. Here's the roots of a cubic. So when x is 0, y is 0. So there. When x is minus 2, this will be a 0. So that will give a product of 0, won't it? So here's the roots then. And this would be x is 3. Now a cubic goes down, up and down, or up, down and up, depending on whether the x cubed is positive or negative. So here, what have we got then? This is a negative x cubed, so it's going to look like this characteristically, isn't it? So it's going to come down, go back up and go back down because of the minus x cubed term. So I'm going to just put it in dotted because it's easier for me to draw like this. But if you were drawing it, you would draw a nice smooth straight line. So it's going to come down, go through the first root, turn, go back up through the second, turn again, and go down through the third. And there's our cubic equation here. Y equals x plus 2, and then 3 minus x, wasn't it? Okay, there's the cubic curve then here. Now we need to draw the other curve, the minus 2 over x. Well, the 1 over x is easy to draw, so let's just draw that in. There's our 1 over x curve characteristically. So it's a 2 over x, so it's just exaggerated form of this, multiplied by 2, basically doubled. And then it's a minus, so this will come down underneath, and this will come out on top. So we've got a curve that comes up from here and goes through here, and down from here and goes through there. So that's what we'll draw then. So it's going to come along here, and it's going to go down, down and turn and go down through there, and it's going to come down here, turn and go down through there. This is not very well drawn really, but I would expect you, if you were drawing it, to draw nice smooth lines here, and these are asymptotes, aren't they? Like so. So this is the curve y equals minus 2 over x. So, okay, we've sketched it, showing all axis crossing points. Well, we've intimated the axis crossing points here. Here's the first one at minus 2, 0. Here's the second axis crossing point at the origin. And then the third axis crossing point is here at 3, 0. So there's only 3 axis crossing points because this is asymptotic to the x and y axes for the other curve. So use your sketch to find the number of solutions to this equation. So part B now. Let's have a look at this. So here we've got x, we've got this stuff here, x plus 2, 3 minus x is equal to, and move this over the other side. So when do these two curves equal one another, intersect? 2 points. So I'll put it up here. These curves intersect at just 2 points, and we can label them P1 and P2 as shown. So here's P1, and the other intersection point was here, which is P2.